In the discussion surrounding intelligent design, ID, it's crucial to address the scientific and logical requirements needed to effectively challenge or debunk a theory, and to differentiate this from merely holding a different opinion. Let's clarify how scientific theories are generally developed, the specific claims of ID, and the nature of empirical testing in science. Development and validation of scientific theories. Scientific theories arise from hypotheses that explain observations within the natural world. These hypotheses are rigorously tested through experimentation, and as empirical evidence accumulates, the hypotheses can evolve into widely accepted theories. Importantly, the initial lack of complete testing or unresolved questions within a theory does not invalidate it. Rather, it highlights areas for further investigation and refinement. Empirical evidence and intelligent design. ID posits that certain features of biological organisms are best explained by an intelligent cause due to their complexity and the high improbability of such features arising from random, unguided processes. An example often cited by proponents of ID is the bacterial flagellum, which is a rotary, motor-driven propeller with multiple interacting parts necessary for function. Proponents argue this complexity is indicative of design because the removal of any one component results in the loss of function, implying that the system could not have arisen through gradual modifications. Each part had to be in place from the beginning for it to work. Testing. Intelligent design. You've asked for specifics about non-theistic scientists conducting tests that either support ID or comprehensively debunk it through direct experimentation. This request highlights a misunderstanding about how some aspects of scientific theories, particularly those involving origins, are tested. Direct experimentation in the manner of laboratory-controlled tests may not always be feasible, especially in fields dealing with past events, like origins of complex biological structures. Instead, researchers use a variety of methods, including comparative genetics, simulations, and reverse engineering of biological structures, to test the plausibility of naturalistic explanations versus designed origins. While these methods may not fit the narrow definition of direct experimental testing, they are legitimate scientific approaches to evaluating the validity of competing hypotheses. The gap in abiogenesis and evolution. Regarding abiogenesis, it's important to distinguish this from evolution. Evolutionary theory, which is well supported by evidence, explains the diversity of life from existing life forms and does not address the origin of life itself. That's the realm of abiogenesis. The ongoing challenges in abiogenesis research do not undermine evolutionary theory, nor do they directly support ID, but they do illustrate significant gaps in our understanding of how life began. ID raises questions about whether natural processes alone can account for life's origins, suggesting that some features might be better explained by an intelligent cause. Conclusion. To effectively debunk ID, one would need to demonstrate through comparative analysis, simulations, or theoretical modeling that complex biological systems can arise without foresight or planning. Simply asserting that ID is invalid because it involves a designer or because it does not fit a preferred narrative is insufficient. Such a dismissal does not engage with the underlying scientific questions ID poses about the origins and development of complex biological features. Thus, a robust scientific critique of ID would require more than declaring it a mere narrative. It necessitates substantive engagement with and refutation of the theory's predictions and postulates based on empirical evidence.